Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. In this video, I'm going to do what my tagline says. I'm going to go over some things that I had some problems with in hopes that maybe it helps some people out. When I decided to do some Bluetooth work, I went out and I bought an HC05, and I thought, it doesn't really matter what you buy, they're all about the same, because that's usually the way it is on Amazon. But it turns out that the HC05 is only one side of it. You can't make it a master. So then I thought, well, okay, something's not right there. So then I went and bought an 1809, this one that I show right here. Well, when I went to hook it up, it seemed to be fine, but then I couldn't get it to work on my phone. And then I found there was a special Arduino app you could put on your phone, and then it worked like that, and it was great. And then finally I did a little more research, and then I found an HC06. So I bought an HC06, and that seems to be the one that does the trick. But I thought I would just show all three in a video, and maybe some of the problems that I had with them and why I've settled on the HC06. So this is the schematic that I'm going to go off for this. In the end, I didn't use these resistors, but I would recommend you do. Don't follow what I do, or I guess do as I say, not as I do. I didn't have any problems. I didn't blow anything out, or at least I haven't so far. I just run the connections right into the receive, and it seems to work fine. But if I was making something for production, I'd probably throw those resistors in just to knock it down from 5 volts to 3.3 volts. What I have is a 1K and a 2K. One side of one of these nanos is going to just be the dummy side. It's just going to display data on a little OLED display. It's going to receive the data in from the other one. We're going to be mainly looking at this one over here and showing you what the AT commands look like and some of the issues I had. But just to make sure that they're working, we'll have it talk back and forth between the two devices. And this is a camera I have set up on it. I have it running right now, and I already have this side over here is the dummy side. It's already running, and I have it counting up every second just to have us have some feedback, and it's going to send this signal over to this device over here, over to the other Nano. Right now I have them connected to the serial port from this one to the serial port on that one. So when I pull up the Arduino and you see the serial monitor, you'll see the seconds counting up. And then when you type something on the serial monitor from this one, it'll transmit over and it will show up on this display over here. I'm going to quickly go over the dummy side of it, the side that I just have for feedback. I have the display set up here. It uses a SPI interface. I'm just using a library for this. It's not too sophisticated or anything. I am using a software serial so I can use pins but yet still send something to the serial monitor if I need to. I'm going to call that one serial 2. If you're using a Mega for this, you wouldn't have to do this portion of it. You could just call it serial 2. I'm going to use an asynchronous delay, so I have two variables for that. I have the delay that I'm going to use, which is every second or 1000 milliseconds, and then I have the async delay itself. When you write to the display, you have to also erase from the display. So I have two variables that are going to be unsigned longs. One's going to be the old milliseconds and the new milliseconds, and that way I can overwrite. I'm going to use the variables that I use from the connection since this is a serial transport. I'm going to use the data from display, DFD. If you're familiar with my videos, that should make sense. But once again, we're going to have to erase the data from the display, so I have old DFD also. In the setup itself, I start the two serial ports, I start the SPI interface, I initiate the display, and then down here I clear the display. And in the loop itself, I just check, and if serial 2 has data on it, then I clear out my data from display. I wait 30 seconds to pull all the data, or 30 milliseconds to pull all the data in. I use my serial 2 available and I collect it all, store it in the data from display. And this is something you would type on the serial monitor in the other Nano, and it'll come across, stored in the DFD. I don't anticipate there being any errors, but if there are, I'm going to print the DFD on the serial port itself. We're not going to have that open during this, but if we needed to, we could get that. I'm not going to get into how the displays work, but this is how you would erase it. When you set it to black, you're going to erase it for this particular display, the color, because it's just going to overwrite what's there in white. and then we'll set the text size. We'll set where it's going to be, which is 5 down and 0 over, and then we write the data we want, which in this case is the old DFD, and then the display.display actually writes the data to the display. And then after we've erased it, then we'll write the new data, so we'll set the color to white. Well, everything else will be the same, 1 and 5, 0, and then we'll send the DFD itself. But just so we have it the next time through, we'll make old DFD equal to DFD, and that's how we erase it up here. Now for the timer portion of it, the data we're going to send to the other Nano, we're going to use our asynchronous delay. We're going to run it every second, and here's where we reset the delay if we need to. But down here we're going to set new milliseconds equal to whatever the current milliseconds are, and then we need to write over the whatever it was. So just like above, we're going to set the text to black, we're going to set our position. In this case we're going to go 5 down. Oh, I got that backwards. We're going to go 5 over and 15 down. And the other one was 5 over and 0 down, and that makes sense because the message will be at the top and this milliseconds will be down below. Then we just send the old milliseconds in that color, and we'll overwrite anything that's there. And then we'll write the new one, which will set it to white. Our position is the same, but we're not going to show the decimal points or the milliseconds. We're just going to show it in seconds. So we're going to divide it by 1,000, and then we'll display. And then we'll set the old milliseconds equal to the new milliseconds, so it's this value when we come back through it and we overwrite it. And then we're going to print serial to print that value out so it heads over to the other Nano. Now I'm going to show you the code that's in the other Arduino. Now this code in this other Arduino is about the simplest code you can write. We'll have our software serial port, so that way we can have the physical port that we connect between the two, and then we have the internal one so we can use it to display the data. And so in our setup we just begin both of them, serial and serial 2. And then for the loop we're just going to continually look at both the serial ports, and whatever we see on one serial port we're just going to write it to the other serial port. So if there's data available on serial 2, we're going to read it from serial 2 and write it out serial 1. If there's data available on serial 1, we're going to read it on serial 1 and write it to serial 2, and that's all we're going to do. So now if we start the serial monitor, we should see those seconds coming through. And you can see that we've got 1300 and the seconds match up. I'm hoping this comes through the video okay. And then if I type something in here, like hello Nano, it shows up over here. And we have it set up so if I send something else, like goodbye, it should erase the hello Nano and then write goodbye. And in this case we just have them wired directly. So there's no Bluetooth activity, it's just the setup. I just wanted to do that to make sure that it works. And now we're going to add a Bluetooth device. We're going to add the original HC06. And this is what it looks like. It only has 4 pins on it. And when I first got it, I thought it was really great because I plugged it in, my phone saw it, I made a little app on the MIT site, and it just worked and it was great. I even have a video online going to that MIT site where I used this device. But where it works bad is if you try to make it a master, it doesn't work for that. I'm going to unhook the serial port direct and I'm going to plug this in its place. So what I did is I have the serial port on this Nano on this side, which is connected to the computer so I can see it on the software or on the serial monitor, run over to here, and I'm going to use this location later for the AT09 and the HC05, and then I just have it running to this device here. So I clear the output, and if you're not familiar with this, there are AT commands. And normally when you type AT and hit enter, you should get a reply that says OK. But in this particular device, you don't get that. The only thing that I found that this device, this HC06, can do is that you can rename it. And you do that with the AT plus name. And it says, OK, set name. So what you would do is you would do that AT plus name, and then you would just change the name. I'm going to show it to you on my phone and how it can change. And you can see it comes up as an HC06 as far as an available name. Now we'll go and change the name. We'll set it to CC HC-06. I want to keep it the same so I can tell them apart, because we'll be dealing with the other models too. Now sometimes it takes a minute, and sometimes you have to actually connect it when you make the change, because the phone doesn't quite get it. So if I hit, and you can see once I hit pair with, it came up with CCHC06. Sometimes it does take a minute for it to change. In that case, I'm not sure if it's because I selected it or what, but you can change the name on an HC06. But what's strange is you should normally be able to type in AT plus name again, and it should come out as saying set name, or it should have the name, but it doesn't for some reason, so that's kind of strange. But the HC06 does connect with the Android just fine, and but you can't make it a master. So that's why I went ahead and purchased I just purchased another randomly and got the AT09. So we're going to look at that one next. Now this is the AT09. It looks very similar to the HC06, so I put a sticker on it so I can tell the difference. I've named this one AT1 for attempt number 1. And I already have the circuit board wired, or the breadboard wired for it. And I plugged it in here. I've got my transmit and receive right here, and then in the back I have the power. And this is the similar thing, only in this one, when I type in AT, I get the OK, which I didn't get in the other one. And if I do AT name, I get the name ATT1. But for this one, you can also see the roll. And a roll of 0 means that it's the dummy side or the slave side, and a roll of 1 means it's the master side or the controller side. And you can also see the version. And this BT05, I believe, is why sometimes you'll see these AT09s listed as BT05s, or sometimes you see HM10s. They call these AT09s, or what I call an AT09, different versions, or by different names. But what I'm going to show you now is I'm going to try and connect this, since it is in the dummy mode or slave mode. I'm going to show you what it looks like when you try to connect it to your phone. You can see that it comes up as it's available to pair, but when I click on it, it says pairing, but it never actually pairs. And if I go back out, it doesn't show up on there. I've just got my headset and my truck are the only two that are on there. But if I run this other app, this Arduino Bluetooth app, you can't really see it in that picture, but I'm going to open it. It looks like this. And if you hit search, you can see that it sees that ATT1. And if I hit enter, you can see that it connects. But I have to use this Arduino Bluetooth app. If I go to the serial monitor now, you'll see that data will go back and forth. You can see that it says serial present down here on the display. If I go down here and I just type in some text and hit send, you can see that it appears up here. If I go up here and say hi and send it back, you can see that it showed up right here. So we have communication going between the two. But my problem with the AT09 or this device, and it may be my phone, I'm not sure the reason, but I can't use the regular app in there. So when I go to the MIT app that I built, so when I open this app here and I select this, I don't see the device in here. And I want to be able to build apps through that MIT program or that MIT website. So at that point I decided the AT09 isn't going to work. Now just to make sure though that it does work with other devices, or in case I needed to use this for something else, I'm going to go ahead and go through setting it up between two of them to get them to communicate between the two Nanos that I have. So I disconnected it from the phone, from the phone, and now I can do the AT commands. When you have it connected, you can't use the AT commands because whatever you type in, it sends it over to, it's using the Bluetooth connection for transmission. But once you've deleted it, then you can go back to this. And if I want to use the Bluetooth to pair the two together, I have to have another AT09. And so I've got this one set here, and you can see they're both blinking. But they're both set up to be the slave end on it. So we need to program this ATT1 so that it will connect. We do that right here. And the first thing we want to do is we want to change the role. We're going to set it equal to 1. And it said OK. And then the next step, in order to define what we want it to connect to, since there could be a lot of devices out there, we have to inquire. If you do the INQ and you follow with a 1, it starts the inquiry mode. But if you want it to stop, then you would do it again with a 0. But in this case, it should find it. And it did. It found it right away. And you can see that it found one device out there, and I only have one device on right now. I shut that HC05 off. So when I want to connect to it now, I do AT connect and then the number you want to connect to. Like if it found 3 or 4 of them, you'd have to know which one you want to connect to. But in this case, we're going to connect to 1. And you can see that they both went solid. So now we're connected. And now the AT command shouldn't work. If I type AT, you can see that we didn't get any connection. But if I take my wires and hook them up now that we have this device connected to this Nano, if I type IT again, or AT again, it should appear here. And you can see that we're getting the seconds. And there we did. We got the AT. So instead of functioning like we would want it to, it's functioning in a connected mode. And now the only way I know of to disconnect it is to disconnect the power to it. In order to make it connect, now that we've plugged it back in, we'd have to run those commands again, the inquiry and the connection. But since I can't use this with this MIT app, I've decided to just start using the HC line. And the next one we're going to go over is the HC05. Okay. And like I said, the HC05 looks very similar to that AT09. It took a little bit of research to find the information that I needed on this. But this one works a lot better, at least from my point of view. Now the HC05 uses this enable pin, which is the pin all the way over here on the right, and then this blue cable. If I have this blue cable plugged into, or that enable set high, and I unplug this and plug it back in, I get a different flash pattern there, and the AT commands don't work. But if I have it in low and I plug it in, I get that flash pattern and I can use the AT commands to configure it. And this one connects, I'm not going to go through it on the phone, but I see it right away. The HC06 pops right up. You can rename it just like you can on the AT09. That part of it is just about the exact same. But the thing I like about this one is it also will connect to that HC06, and you can set it in a mode so the second you turn it on, it just looks for the nearest thing and just connects. You can also set it to be a specific connection to a specific MAC address, but in this case we're just going to go through setting it up to be just whatever it can see it connects to. Like I said, now that I have it up and it's powered, I have to move this blue wire back to high. And then when we type the AT, we get the OK. Now if I do AT plus roll, you can see that it's set to roll 0. You can also do AT plus version. If you do a quick web search, you can see all the AT commands for this particular device. Oh, you can see I sent something through here. That's kind of interesting. At one point something wasn't hooked up, or maybe when I move something around. In order to connect, we have to change the roll to 1. But you need another symbol. It has to be equals 1. On the AT09 it was just roll and then 1. On the HC05 it has to be equals. So now the roll has been changed, but now we have to change the connection mode. And it's C mode, and then we'll set it equal to 1. So now the second it sees a device, it's going to connect to it. I have this HC06 here. And I powered it up. And we're going to move this cable, this blue wire, which is on that first pin, to low. And you can see now that we're connected. Now if I go to this again, we should be able to send data back and forth. Oh, and you can see we're getting our seconds. And now I'll type, and we get hello and goodbye. And so we're connecting. And I found that this is probably the simplest setup of the ones that I have. Like I said, I probably would have just stuck with this HC06, but it's stuck in dummy mode or slave mode, whereas the HC05 you can do some things with. Now I did notice on this HC06 though, there are pins on either side, so if you want to cut this plastic layer off, maybe there's some way to do it, but I preferred to do it the easiest way possible, so I'm just using, for this example, I'm just going to use the way it comes. I didn't make any modifications, I just plugged it in and did everything with software. I don't really have a recap for this, but other than just to say I originally started with HC06, but it only goes one direction. I bought an AT09 and I liked it just fine, but I couldn't connect to the phone the way I wanted to use the MIT apps. So then I did a little more research, found an HC05, and overall I just like the way the HC05 connects, because for the most part I'm either going to put in a defined MAC address so that I compare two of these devices together, or I'm going to just be looking for the closest one and try and plug them in the right order so that they connect. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.